Hello everyone, for this demonstration we're going to go over how to optimize scheduling using the network diagram tool, as well as how to estimate cost and duration for a project, as well as how to generate a risk report using a few of our tools here. So first thing, we will open up the Excel sheet with the sample problem for us to solve today. So we've been assigned as the project manager, and there's 4 activities that must be completed for a product launch event. We're going to estimate the most likely project completion date, identify costs and scheduling risk, and generate a risk report. So the project launch event involves 4 key activities: catering setup, marketing material, venue preparation, and then event execution. There's a little bit of interdependency and concurrency for this project, which will help us demonstrate the versatility and effectiveness of our tools. So starting out with catering setup, which will last 8 days, marketing materials, 4 days, rough estimate, and these 2 must be finished before venue preparation can start. Actually, it says venue preparation must start 2 days before catering setup and marketing materials finishes. So we'll just put in here to stay organized. Finish to start relationship -2. That means it'll start 2 days before the other 2 finish. And then CS and MM as catering setup and marketing materials will be predecessors here. And then event execution will start after everything else is completed. So after catering setup is done, as well as venue preparation. And it will last roughly 7 days and 2 days for event execution. We will do a split screen to help us follow along, and then go to our project manager helper.com. We'll start with the advanced network diagram. It will automatically load with a sample project entered here, and you can just calculate just to see how it looks with the advanced relationships here. So we'll set up a split screen for it. We'll remove some of the rows because we only need 4 for this simple project. So we'll start out by putting in the information. So we have catering setup, marketing material, venue preparation, and event execution. And then we plot the predecessors. So for this one will be CS, MM, and the duration will be 7 days, 4, and 8. Finish to start is the default relationship, meaning if there is a predecessor entered, it assumes that the predecessor must finish entirely before the new activity begins. Pretty self-explanatory. There's also options for start to start, finish to finish, and start to finish relationships. Next, for this one, we're going to determine the lag time. So lag, we're going to do -2, meaning it starts 2 days before the previous 2 activities finishes. That's what this means here. And then event execution, we're looking at 2 days rough duration. And for the predecessors, we're looking at venue preparation as well as catering setup. We'll generate the diagram. You see what it looks like visually with the dependencies here in the middle of the lines, and then the base duration on top of each activity. Highlighted red will be the critical path. The critical path is basically the overall duration of the project. If there's any delays in CS, VP, or EE, that means that that delay will transfer to the overall project. So right now the project duration is estimated roughly at 15 days. If we add 1 day to VP, if instead of 7 it takes 8 days, and I can demonstrate it here, this overall duration will go up to 16. Yep, 16 days, and automatically the software will tell you what the critical path is. It's very easy for a project that's only 4. But so you can see, if you thought this was complicated, imagine a project with 100 activities. This will help you generate that and see it visually, as well as it'll help you with scheduling. Next thing, you can see there is float. Float is how much an activity can be delayed without affecting the overall duration of the project. So for marketing materials, we can delay up to 4 units of time without it going over 15 for the overall project. That's very useful because here you can see if you take resources or employees away from this task and you allocate it to any of the others, since it's happening at the same time as CS, we can take some members or resources from here to add it to here to reduce this duration and increase this one, and it could help you reduce the overall duration of the project. For example, if we transfer some resources from MM to CS, MM goes up by 2 days, CS goes down by 2 days. Now you generate the diagram. You can see the whole thing is red. There is 0 float, meaning there's no more wiggle room, but the overall project duration now went down to 13 days instead of 15 days. So this is another way that you can use this tool. I'll reset it to what it was before. Great. So next thing, we have the project set up here in accordance with our chart here, which was generated from the paragraph describing the project. Next, we copy the output, and you can either leave this page, or if you want to keep it for reference, you can keep it there. Go back to projectmanagerhelper.com. The network diagram tool, advanced, it links pretty well. It works with the advanced schedule predictor, which runs Monte Carlo simulations in parallel, which is quite unique for software. Most softwares that cost a lot of money, proprietary to companies, or that you can download or students can use, they only run Monte Carlo simulations in sequence. So you can use it for cost, for adding cost very well, but it's not very good for activities and projects such as this one that have a lot of interdependencies and connections. They're practically useless for those, so that's why I designed this tool. Once you load it, it automatically loads each activity. The base duration, which is this one, is a rough estimate. We're not really going to use it. We're just going to use it to QC that the numbers make sense. And then the dependency configuration. So it automatically loads each dependency from our network diagram. And then the number of trials we want to do for the simulation. Now, the only thing that's left is to examine the data, determine the type of distribution of the data. For our tool, which is also quite unique, most tools you can find online for a big fee, they only have a few of these distribution models. Ours has a lot of them, most of the ones that are typically used in advanced statistics. My favorite one is PERT, where you estimate the optimistic, most likely, and pessimistic value of cost or duration of an activity, and it will generate, using Monte Carlo simulation, it will generate a number using an equation that adds a PERT distribution to help you estimate it. So, but here we don't have to do that because we actually have some data that we pre-recorded or pre-generated, and we have it saved in Excel here for each activity. So we're going to focus on scheduling right now. This is the duration in days for each of the activities. I went ahead and I organized it all. So this is CS, VP, MM, and EE, the duration for each one. As you can see, the event execution has a fixed duration. It's going to take place over 2 days. However, we have historical data of 100 observations for each one of the other ones and how long roughly it takes. Again, this was generated information. It's not truth data, just to demonstrate this tool. So how do you determine what type of distribution the data has and what parameters to put into our Monte Carlo calculator? Well, we have a tool for that. So we'll keep that page open for now, and we'll go back to projectmanagerhelper.com, and you want to go to tools. Go to tools here and select the we're looking for distribution, data distribution analysis. This tool, it can be used for data distribution analysis as well as for our regression calculator and predictions. I can show you that here in a bit. How this tool works is, first you want to copy all the data over from Excel that you have. You can have as many variables as you want, so you add variables here. We'll do the for duration. Just paste, make sure there's no numbers, that is formatted appropriately, and then you can label the variables. So this one be CS duration, VP duration, and finally event execution duration. Now you import the Excel data and it automatically loads all 100 observations. Next, you want to go back and calculate statistics. That should have generated 4 charts, and it also tells you what the best fit of the data is. So in this case, for CS, it says uniform distribution. It also gives you all the parameters that you may use to input into the Monte Carlo tool. Uniform distribution typically means that the data is quite random, so that's fine. So I like to just copy, go back to the Monte Carlo, select for CS uniform distribution. Now all you need is a minimum and a maximum. Just paste, make sure you clean up the formatting to remove any letters or parentheses. All this should have is a number, comma, and a number, so min max. And as expected, it's kind of between this base duration number, which is a very rough estimate. This will give us a more precise number based off actual historical data. Next, we'll look at the other one, This one, the best fit is a PERT distribution. As you can see, there's more of it's heavier towards the middle and less here on the sides. So for this one, we want optimistic, most likely, and pessimistic. We go back to select PERT distribution, clean up the numbers here, how they look. If you do input the format incorrectly, it'll just generate an alert saying that it will skip that one for the calculations, and then that will trigger you to go back and you can QC, make sure that the data is entered with just numbers and commas. And then you look at here, duration, roughly 4. Yep, makes sense, falls between this data. Next, go back to get the other two. This one's another PERT distribution for VP. But you can use any of those types of distributions. And for finally, we have a normal distribution, which is just 2 because it's a fixed duration. So you can enter that many ways, but the easiest way is probably just follow here. So just put normal distribution, mean 2, standard deviation 0. Normal distribution, the mean is 2. Standard deviation 0. That means that it'll never deviate from 2, essentially. So it's always 2. There's many ways of entering that, but this is the easiest way. Yeah, so you have all your data entered here in Monte Carlo. Before I run the simulation, I want to go back and show you something. If you want to calculate if there's any relationship between any of these variables, you can go back here and you can calculate linear regression. It will run so that when you select here the variable, do you select CS duration? In this case, it will be the independent variable, and it is testing separately if there is a linear regression relationship between CS and all the other 3 variables. So you can see here, if you can look at the R-square, there's none for any. If any of the R-squares were 0.15 or higher, then that could indicate that there is a relationship that you can use to make predictions. So let's say that there is a relationship. If there was, you can basically let's say that you know that you're estimating the duration of CS to be 10 for this project, or you know one of the variables. Now you can use that to predict the other three if there was a relationship. In this case there isn't, but you would just enter 10 predict and it will generate a prediction for each one. But this is not a good these are not good predictions, just because the R-square is too low. And this one is always 2, so yeah, it shows that it's 2 here, so that makes sense. But yeah, just another way that you can use this tool. We do have a multivariable linear regression, so if you wanted to calculate if all these variables, if any one of these depends on any of the other ones, you can use the multi-linear regression, but that's an example for another day. You can also calculate polynomial relationships, which can be better fits, and you can enter as many degrees as you want here for those. But that's beyond the scope of this demonstration. So we'll go back to the Monte Carlo. Now we're gonna run 10,000 simulations. You can do as many as you want to see what the actual predicted duration of the project is. Run the simulation. That's what the frequency and duration look like. So now if you wanted to predict you wanted to present to your bosses or project sponsors or stakeholders the 85 percentile, or not percentile, the 85% probability of your project being completed, you can go here, slide to the 85, and then basically tells you there's an 85% chance that the project duration will be less than 16.7. So you can use that. Let's say that your managers wanted you to finish this project within 16 days. Now you can go back using the data that you gathered and sound statistical analysis to present to them this. There's a 67% probability that you can complete it within 16 days. However, that means that there is a 33% risk that the project will go over schedule. And that brings me to the last tool I wanted to demonstrate today. Back to tool, we want to do risk register and assessment. So this is how you can model risk. Let's say they wanted you to complete it in 16 days. So you can model that project over 16 days. That is the risk. Now we already calculated the probability using Monte Carlo, so we can go back here and you can see 33%. So there's a 33% risk, and then the impact. Let's say you were told if the project goes over 16 days, we're gonna scrap the whole thing, or whatever it might be. So you can attribute an impact, let's say 9 from 1 through 10. And there's a qualitative analysis techniques to help do this. I invite you to look into Delphi. That's my favorite one, where basically it generates a consensus. But for this one, we're just going to predict it. You could also follow these links. So this schedule was parallel because it had some concurrent and some tasks that were happening at the same time, and it was quite complex. So that will take you to the Monte Carlo that we just used. However, if you were calculating costs, for example, costs going over, let's see, go back to the event prompt. So you were approved $5,000, so you want to see what the probability of the cost going over $5,000 is. If you go over, the project will no longer be approved. So let's say the impact for that is 10, and then let's say that if the cost goes over 4,500, something else could get canceled. Let's give it a 7 just for the example. And then you wanted to calculate these, you can do Monte Carlo sequential, which is a simpler Monte Carlo tool. Now you can add the variables, and then I already preloaded the data here for cost. So if you go back, you have the same data that we had before for scheduling, but as far as cost estimations, you select those, go back to figure out the type of distribution that they have. So easily just paste that here. And then just make sure I keep the labels correctly. Yeah, this should be in order, so we'll do, and either way it won't matter at the end because the number will be the same because it's just adding them up, so we don't necessarily care about them as much unless you are looking to put specific deliverables into the cost register. For example, if you wanted to put the risk of the VP cost exceeding a certain amount, you can also model that, and it'll be quite simple actually. So generate the data, we're going to calculate statistics. Now let's go back here. You can see the distributions of all three. So we have a uniform distribution, a gamma distribution, and PERT, and then finally binomial distribution. Okay, that's cool. And then all the parameters that we'll need to plot each one. So let's say that we wanted to estimate the risk of the event execution, specifically exceeding $610. So we'll go back here, binomial, we'll copy this data. Cost of event execution going over $610. You select binomial. It wants the N and the P. So we'll clean this up. Now, if you just want to calculate that, you run 10,000 simulations. You can easily do that. Here it is. It looks a little wonky, the data, but you can run more simulations. That should make it a little bit smoother. Or not. Oh, I think it's still running. Too many simulations, maybe I crashed it. Okay, so you want to calculate the risk of over 610. So you can see here, stays fixed for this duration. Interesting. Math is cool. So the probability that it'll go over 610 is about 19 or 18%. So you can enter that into the risk register. 18% risk. And let's say that if the event completion will go over that, you basically the impact, trying to come up with like a made-up impact. It would affect the output in such a way that the project will be hurt. Let's give it a 5. I'm not gonna think about it too much. Now let's add the entire cost and let's assess. Sorry, what did I do? Okay. Cost of EE over 18, sorry, over 610 was it? The probability was 18 and the impact was 5. Okay, now we'll measure the entire project, the risk of the cost being over 5,000. So you go back to the distribution just to copy the rest of them. So CS is uniform distribution, so we'll input that. Uniform distribution, it has a minimum and a max, and it's pretty much random in between there. So the Monte Carlo tool knows what uniform means, so it will calculate that. Next, we will do VP, which is a gamma distribution. Interesting. Gamma, so we want the shape and the scale. Preloaded that here. All right, and finally EE, event execution, and that one is a binomial distribution with N650 and P of 0.93. Binomial distribution. Again, most software you can find online for a lot of money. They don't have as many distribution models. They also don't tell you what type of distribution data has. It takes a lot of statistical knowledge to be able to do something like this. in somewhere like Excel, for example. So we'll go back to 10,000 simulation. Now, when we run this in sequence simulation, it will calculate the added probability. So run simulation. Looks a little bit cleaner. Shifted towards the left side. So the risk of the project going over $5,000, just go to 5,000. Looks like it's about 14%. So you come back to the risk register. There's a 14% chance, and it'll be a really big impact on the company or the project. And then 4,050. Let's say this is our target, and the risk that will exceed that, we'll calculate it. Just go back to 4,500, and it'll easily tell us what that is. There's only a 37% chance we'll stay on budget, on target, which means you're looking at 63% that will go over that. So we will input 63% here. And the impact to that will be 5. Let's say the impact to this will be 3, just to demonstrate it. Now you want to plot the risk, and it generates this graph, this heat map graph. The riskiest is in red. It means there's a higher probability that it will happen, it will come to pass, and a higher impact. Now next, you want to trap the risk by sliding this bar. So in this case, there's no risk are really high with the high impact. That would be catastrophic. That's good, but you still want to do some risk mitigation. So if you slide the bar down, you can trap these top 3 risks. This one is a minimal impact, and it's not very risky, about 18% chance. So we trap the highest risks, and that automatically generates this. So project going over 16 days, you want to use, per the pinbook guide, the types of risk mitigation. We can avoid, mitigate, transfer, or accept. In this case, we want to mitigate it. We don't want the project to go over 16 days. So we can just go back here, and we can use the float to help mitigate. So let's reallocate assets from MM to CS. And we determined that we can mitigate some of that risk from our calculations earlier. So reallocate from MM to CS assets. Yep, and that should reduce the risk. That should reduce the probability of that high impact that the project will go over 16 days. And you could even model what that would look like too. Costs going over 5,000, probability 14, impact 10. Just an example, you can accept that risk, or you can transfer by requesting additional funding. Risk funds from other department. That's just an example. Accept risk. Finally, once you have that, you can even generate a risk report that ties it all together with all of the risk in the risk register. This could be 20 different risks. You could label them with smaller labels so it looks cleaner if you want, and then the mitigation plan as well. And this could be something that you can present to your stakeholders or whoever's approving your project, or your supervisor. This concludes the tutorial for today. Thank you for watching, and see you next time.